Today we're going to cover two related rates problems, both exploring rates of expansion. One involving a growing puddle and the other a balloon gets filled with air. Related rates problems like these involving simple geometry are pretty common on tests and quizzes, so it's definitely worth taking a look at. And even though these type of problems are usually pretty basic, it's a great place to get acquainted with related rates and get to know the process. Especially because the more complex related rate word problems in calculus usually involve some sort of geometry. This is a pretty broad category, so there's no one magic formula that works for all of these problems. But if you have a basic understanding of geometric shapes and their properties, for example, surface area and volume for 3D shapes or perimeter and area for 2D shapes, you should be able to solve these out without too much trouble. So get out your pen and your paper. Feel free to pause this video and run things back while you follow along and take notes, because we're going to be moving fast. Now let's get to work. So for our first example problem, as always, let's start by reading the problem. Water leaks onto a floor from the pipe in the ceiling, forming a circular puddle. The radius of the puddle grows at a rate of 3 centimeters per second. How fast is the area of the puddle increasing when its radius is 8 centimeters?
Before we jump into the problem, we need to understand it, so we draw a picture of the circle and we write our formulas for circumference and area. With this understood, we can list out the given values from the problem and figure out what we need to do with them. In this case, we need to find out the rate of change of area over time. So it's time to start working on the equation. We write down the area equation and derive it with respect to time. Now we can plug our given values into the derivative to isolate dA over dt and find our solution. And remember, when you solve, always make sure that you report it with the correct units.
So that first one really wasn't too bad, was it? The biggest hurdle when approaching these problems is the fact that they're word problems. And being able to communicate the words that are in the word problem into actual functions that you can derive is the biggest challenge. But if we stick to the problem solving process that we used in the first one, we can simplify this challenge significantly. Now, before we try our hand at a more complex problem involving three-dimensional geometry, be sure to like this video, subscribe to our channel, and hit the notifications bell. We have valuable academic content to help you stay on top of school, dropping every week, so make sure you stay in the loop. Now let's move on to problem number 2. And as usual, we're going to start by reading it. And it says a spherical balloon is being inflated with helium at a rate of 10 cubic centimeters per second. At the instant at which the radius of the balloon is 5 centimeters, find the rate at which the surface area of the balloon is increasing. Now let's jump in.
Just like the last problem, we start this off by drawing a picture of a sphere and recalling the surface area and volume. This gives us an understanding of what we're working with, and the givens will show us how to use them to find our solution. For this problem, we're given radius and the rate of change of volume over time. We need to find out the rate of change of surface area though. Since we have to solve for rate of change of surface area, let's start off by writing the surface area formula and deriving with respect to time. Once we have the derivative, we can plug in our given values, but we see that we don't have the rate of change of radius. However, we were given the rate of change of volume, and we're going to use that to find dr over dt. So we write out the volume formula, and now we derive that with respect to time. Simplify the expression before we plug in our givens. We can now easily isolate and solve for dr over dt. We need to take this value and plug it back into the surface area derivative. After that, it's a straight shot to finding dA over dt. Just simplify and solve. And of course, don't forget your units.
So looking back at it, these two problems really weren't that bad after all, and I really hope that you found this explanation helpful. If you want to succeed in your calculus class and you're interested in working with me, please click the link in the description below to book a free consultation. Also, be sure to check out some of our explanations on other types of related rate problems, including the one with the ladder sliding down the wall, a person walking towards the street light that casts a shadow, or the infamous water draining out of a tank. Until next time, this is Tawheed with Tutelage Tutoring signing off.